Hello guys, today I'm gonna show you how to set up the AutoDustBoot on a different way. If you follow the installation guide, the suggested way to connect or to control the AutoDustBoot or how to integrate it to your controller is to use the plug, because still that's the easiest way. Why? Because most of the CAM software is already able to insert an M8 and M9 command to your G-code programming, which basically control or send instruction to AutoDustBoot to do the going up and going down. So there's some case that they already use the plot for something else, and question always like, how can I use the AutoDustBoot to control it without using the plot? For example, some of the Rapid Change ATC premium version, it comes with a cover. So cover, I believe, is normally closed, and AutoDustBoot, it behaves in normally open. So they are reversed. So you cannot connect them together. If they are the same, you can, but in this case, you cannot. So the solution is to use a different I/O ports of the SLB EXT. There's actually output ports as SLB EXT provides. Those are SWT1 and SWT2. And in this demo, I'm going to use the SWT1. SWT1, if you go to the SLB EXT documentation on the CNC website, it's mentioned that it's like a relay, a MOSFET relay that can accept I think it's three volts to up to 24 volts. We can use the SWT1 to control our AutoDustBoot. What we're gonna do is there are two pins on SWT. I mean, it doesn't matter the orientation of the two pin, as long as you connect one of the yellow wire of AutoDustBoot, and the second one you need to connect that to any 5 volts from the SLB EXT. I believe there's one 5 volts on the green connector for BFD. So we can tap on that and create a jumper, one of the pin. So I'm gonna show you the diagram. So here is a sample layout. So from the RS485, there's a 5 volt. There's the blue line. It's gonna go to the one of the pin, and on the other pin, it goes the yellow for AutoDustBoot. So that's the only changes. Instead of connecting the yellow cable to the plug, we're gonna connect it to SWT1. The next is if we go again to the, let's actually go to the SLB EXT documentation, type CNC, we got technical manual, and if you just scroll down to the two accessory outputs, there's a switch and aux power. So we can scroll that. So in here, it mentioned here that we have, here. In here, it mentioned SWT1, 2, power 1, power 2. There are P0, P1, P2, and so on. The P is the port that we need to address. And according to documentation, the way we can control this pin through G-code is an M command. So M64, M62 or M63, but I'm gonna use the M64 and M65. M64 and M65 doesn't wait for the response. We just basically send a command. I already wired my AutoDustBoot on SWT. So what we can do is we can go to the G sender. Let me connect my G sender. And if you see my AutoDustBoot, right now I'm just gonna set up the height to the lowest settings just for the demo. So and then if I send a command M64, P, since I'm using SWT1, it should be P0. It goes down. Then to turn it off or to put it up, it's M65, P0. See, it works. So the remaining task is, if you're using a Rapid Change ATC, we're gonna need to update our macro tool change. So in part here, there's an M8. I'm just gonna look on M8. See here, there's a section says ensure AutoDustBoot is retracted. There's an M8 command, and then there's a P64 M64P0. So I kept the M8. I'm using my vacuum, which is connected to a relay to control 110 volts. So if you notice, if I go to the coolant and I click plug, it turns on my vacuum. So basically, I still need the M8. So, but I'm just showing here that I can use M8 at the same time and other M command or other output command on SLB. So here you have M8 and then followed by M64P0. And then there's an M9, which is up, turn it off, which then there's an M65P0. So why? And then there's a G4P100, P0.100. What this section does? Why do I need to, every time I do a tool change, I need to send M8 and then M9 quickly, or M64 and then M65 quickly? The G4 P0100 is a delay. Like this, the command between the two M8 and M9 is 100 milliseconds. And why did I do that? It's just a safety feature that I added on my script, because there's a case that you might just put down your AutoDustBoot and you forget to retract to set it at back, and then you did a manual tool change. What will happen is the controller is not aware that the AutoDustBoot is down. So to make it safer, we're issuing a command to say, hey, expand and then retract quickly. So it doesn't matter what the state of the AutoDustBoot. If it's already retracted, it doesn't harm anything. You will just see a quick going down and going up quickly. But if it happens is already down, it will perform down and then up. So the last action, what it matters is the M9. It will move the AutoDustBoot up. So I can show it to you. For example, don't do if you're doing a test, my suggestion is always detach your lower AutoDustBoot. I'm just attaching it so you can see from the camera clear from the camera that you can see some movement. So I'm just gonna move it a little bit in the middle. So I'm gonna move the Z height. Actually not. Okay, here. I'm gonna attach it. And let's say I put it down. So now it's down. So the controller is not aware it's down. So I'm gonna issue a command M62, which is change 2-bit to 2. See what will happen. Let's go up. So in our case, since I already moved this to SWT1, it's not really the M8, M9 that's doing the work. If we go back to the script, there's a counterpart M64 and M65 that's actually commanding the 88, the AutoDustBoot to move up and move down. So that's the first one you need to modify. The second part is we also need to update our post processor. So we cannot just rely on M8, M9. We need both. In my case, like I mentioned before, I need both. I need the M8, M9 to control my vacuum. At the same time, I need M64 and M65 to control my AutoDustBoot. In my case, I'm using Fusion 360. Also, since I'm using the pre-version of Fusion 360, which has a limitation. Just to let you know, the Fusion 360 pre-version personal edition doesn't allow you to do a tool change to begin with, and also it's also removed the rapid movement. That's the limitation. So if you have a paid Fusion 360, this is not an issue. In my case, there's some guy who already created a Python script that basically what it does is it will generate all individual file for the Fusion 360 for each of your tool or bit, and then this Python script will merge it together into one file, remove the rapid move limitation, and at the same time insert the M6 command. So now you have a single file, which in my case, that same Python file that I need to modify to insert my M64 and M65 command. This is a little bit more advanced for a regular user, but I think if you're using Betrix, that'll be easier. You can just, if you already have, if you open your Betrix and you have your post processor on your Betrix that support vacuum or like a flood control, all you need to do is every time you see an M8, just insert M64 with it, M64P0. And every time you see an M9 on the post processor, just insert M65P0. Actually, in fact, for M64, you don't need it. It's only for M65. Why? Because our macro for the rapid change ATC already have it already does the M64. So if the macro detect M6 command, it will internally inside the macro will already emit an M64. So only M65 that we need to modify on your processor, because that for like the program ends, that's not part of the TC macro. The program ends is part of your program of G code. So if your program end usually has an M9 in the end part of it, so all you need to do is also insert M65P0. So again, I repeat, the counterpart for M8 previously is M64 and M9 is M65. And parameters is P0 is basically representing switch 1. If you're using switch 2, you're using P0, P1, not P0. Okay, let's do a demo. So I already modified my post processor. I already modified my TC macro. I'm just gonna load a sample G code that I have. This one, it's a very small program using 3 bits. So I'm just gonna make sure everything is correctly set up. So just checking my location and my z-axis. So I'm just gonna cut on air, and then for the AutoDustBoot, this is a basic usage. So once you're ready, you attach the AutoDustBoot, you connect your vacuum. So I'm not gonna connect the vacuum right now. I'm gonna lower, and then you just use the control knob to set up the height. Let's say this is your material height. Actually, let's get some fake material here. Let's say this is our material. It's very small. So I'm gonna lower it to the material and double press it. So now the AutoDustBoot will remember that this is our height. So even if I press this, toggle it, to go up, and I'm to go down, it stopped where we saved the storage. So I'm also gonna get demo in the same way. You should always before you begin, you always retract it, but just for the demo, I'm just gonna leave it down because I told you, I discussed before, I put some safety features on my macro that if you left the AutoDustBoot down and then you run the program, it should, every time it execute the TC macro, it will invoke those quick successive M8, M9. Okay, let's cross our finger, let's run it. Okay, works so far. First bit. You notice I also add more 3 plunge now before it's 2 plunge. Okay, that's our first bit. Okay, I also want to mention switching from plug usage to another switch one. It also fixed one problem that my customer raised. When if you're using the plug, when we hit stop or e-stop, it will turn off our plug if you're using the plug for the AutoDustBoot. Then what will happen is it will retract the AutoDustBoot, but the spindle will remain down. So what will happen is the AutoDustBoot will hit, depending how you mount your spindle, the AutoDustBoot might hit the mounting of the spindle. If there's already a improvement, there's a flexible TPU. You can see it will squish hard, and if it's not enough, that thumb screw, the way you screw it, it will disengage the lower dash shoe to avoid further damage. But if we're using a switch one, we can decouple the switch one, turn on up on the stop or e-stop event. I'm going to show it to you. For example, I'm going to run it again. So once it starts cutting, I'm going to show it to you. I'm going to stop the program, and you will see the AutoDustBoot and the spindle won't have that problem. So I'm gonna pause it and then stop. So you see the AutoDustBoot didn't move, and the spindle also, because the spindle doesn't move, so you don't have the collision problem. From this point, we can just raise the Z, and then we can just, well, do it on either the controller or issue a M65P0 command. So that's also advantage of using a different port. Also, I want to mention, by default, if you go to your firmware settings and type event, there's an event trigger 1 and trigger 2. Make sure this is set up to none. This because trigger 1 is tied up to 760, the 750, 750 and attached to 760. So basically the event 1 is attached to event 1 port. And one port is basically our switch SWT1 or switch 1. So make sure you set that to none, else it's still gonna fire that event, because I think by default it's still attached to either mist or the plug. So make sure you turn that off to none if you're using the switch one. Hope this covered, it's a little bit longer, but I'm hoping to cover most of the concern. Talk to you guys later. Bye.